Assalamualaikum warahmatullahi wabarakatuh and welcome to my YouTube channel. So in this video, I will like to explain about the orbitals, the quantum number of atomic orbitals and the quantum number of electrons. So first we go to the first one, which is what is orbital. So in Bohr atomic model, okay, you can see here in Bohr atomic model, you may have heard about orbit, which is the pathway where the electron is travel around the nucleus. This is the orbit. Okay, it is the pathway the electron take to move around the nucleus. So this is the what we call as orbit. So but in this video, I will explain about the orbital that is based on this quantum mechanical model. So the exact location of electron that is described by quantum mechanical model is a little bit different from the location of electron that is proposed in the Bohr model. Okay, so the location of electron that is described in this quantum mechanical model is using the word probability. Means that the three-dimensional region, three-dimensional space around the nucleus where there is a high probability of finding an electron. So you see here, the word probability is used to describe where is the exact location of electron. Since that we are using probability, so means that we will use number to describe the location of electron in an atom. The exact location of electron in an atom is described by first using quantum number of electron that I will explain later. But in order to know the quantum number of electrons, so we need to understand what is the quantum number of orbital first. Okay, so for the quantum number of orbital, an atomic orbital is specified by three quantum number. The first one is the principal quantum number. The symbol is N. The angular momentum quantum number, symbol is L, or the other name for angular momentum quantum number is azimuthal quantum number. Then we have magnetic quantum number. The symbol is M. Based on this picture, we can imagine that our atom is like an onion because our atom is consist of multiple shells. So each shell will consist of different number of orbitals. So bigger shell will have higher number of orbitals compared to smaller shell. Okay, the shell will reflect the principal quantum number N, and then in the shell we have subshell. So the subshell is described by the angular momentum quantum number L. And then in the subshell we have different number of orbital. So the orbital is the combination of N, principal quantum number, L, angular momentum quantum number, and M, magnetic quantum number. So I will explain each of the quantum number one by one. So we go to the shell. So we know that I have explained earlier, the shell is given by the value of principal quantum number. The symbol is N. So the value of N is positive integer starting from 1 to 3 and so forth. Depend on the where is the how many shell depends on the shell. Okay, it indicates the size of orbital. A bigger value will have bigger size of orbital, and then it represents the energy level. So this one you will learn it in SEM. And then the third one is the relative distance from the nucleus. So the greater n value will far from the nucleus compared to the smaller n value. Okay, and then after that, we will go to the subshell. So, subshell is given by value of angular momentum quantum number L. So, the value, the number, the angular momentum quantum number is an integer that starting from 0 to n minus 1. So the value is depends on principal quantum number n. So if principal quantum number is equals to 1, means that the angular momentum quantum number L is equals to 0 because the integer is starting from 0 to n minus 1. So n minus 1, 1 minus 1 is 0. So the L is equals to 0. So it only has one value of L, which is 0. And then if you have n equals to 2, means that your L value will start from 0 until n minus 1, 2 minus 1 until 1. So means that you only have two value of L. How about if you have n equals to 3? So for n equals to 3, the L is equals to 0, 1, 2. Okay, starting from 0, 1 until n minus 1. So 0, 1, 2. So means that n in the shell 3, it has 3 value of L. Okay, each value of L will determine the shape of orbital and designated by using letter. So L equals to 0 is a S will be used, is designated by using letter S. So L equals to 0, we call it as S subshell. Okay, for L equals to 1, so the designated letter is P. So means that L equals to 1 is a P subshell. And then L equals to 2 is the D subshell. And L equals to 3 is a F subshell. So this is the name of the orbital. Okay, so the letter is derived from the name of spectroscopic line, which is sharp, okay, for S, principal for P, diffuse for D subshell, fundamental it represent the F. Okay. Okay, this is where the name of the subshell come from. So the S is sharp. So this is what the line, the spectroscopic line looks like for sharp. And then for principal, for P is which is principal. So this is the line of principal line. Okay, this one is the diffuse line, and this one is the fundamental line. So you may read more about it in this website. Okay, and then we go to the next one. Each subcell is named with n value and letter designated. So means that if you have n equals to 1 and L equals to 0, means that this orbital is called S1, this subshell is called S1S subshell. Okay, if you have n equals to 0, L equals to 0, means that the name of the subshell is to S. And if you have L equals to 1, so the name of the subshell is to, so number of subshell in each cell is equals to n. So number of L that you get is depends on the number of it depends on the principal quantum number. So for example, if n equals to 1, means that you only has one subshell, which is 1 S, because you only has one value of L, which is 0. And then if you have n equals to 2, so in the shell 2, you will have two subshell, which is 2S and 2P, because the L value for n equals to 2 is 0 and 1. Okay, if you have n equals to 3, so means that you will have 3 subshell, which is 3S, 3P and 3D, because you have 3L value, which is 0, 1 and 2. So how about orbital? So orbital is a combination of n, L and and M. So M is, I have explained about M and L. So right now I will explain about M. So M is a magnetic quantum number. So the integer starting from negative L through 0 to positive L. So the value depends on the L, azimuthal quantum number. So if L equals to 0, means that M is equals to 0. If L equals to 1, means that value of M will start from negative 1 through 0 and then end with positive 1. So it prescribes the 3D orientation of the orbital in space around the nucleus. So the number of M value will determine the number of orbital you have in your shell. Okay, so the formula is 2L plus 1, either 2L plus 1 or N squared. Okay, for example, in shell 1, in N equals to 1. So the value of L is equals to 0, M equals to 0, means that in this shell, it only has one orbital, which is 1s, because it has only one M value. Okay, you see here, it only has one M value, which is 0. So this orbital is named as 1s. Okay. For n equals to 2, you have two value of L, which is 0 and 1. So each value of L will have, for L equals to 0, the value of M is 0. For L equals to 1, the M value is negative 1, 0 and positive 1. So when we see here, in shell 2, you have how many orbitals? Okay, you have 4, because it has 4 M value, which is for L equals to 0, M equals to 0, L equals to 1, M equals to negative 1, 0, positive 1. So the total orbital here is 4 orbital, because you have 4 M value. So 1 is here, 1 is 2 S orbital, and the other 3 is the 2P orbitals. Then we go to the shape of orbital. So I have explained earlier, you have S orbital, P orbital and F orbital. So in this video, I will explain only the shape of S orbital, P orbital and D orbital. So for S orbital, it has spherical shape. Okay, like this, it has spherical shape. So the sphere only has one orientation. This is because the S orbit, the value of L for S orbital is 0, means that the value of M is 0. So since the M value indicates the orientation, means that and the M value is only 0, so means that the sphere is only has one orientation, because of the value of M is only 1. Okay. Okay, this diagram show the probability distribution of an electron in S orbital. So we have one S orbital here. So what we see here, one S orbital is smaller compared to 2s orbital. And then when we look at the 3s orbital, it is bigger compared to 2s and 1s, because because even though it is the same type of orbital, but the n value is different. For 1s, the n value is 1, this one 2, this one is 3. So I have explained before, the principal quantum number in the name of the subshell or in the name of orbital indicates the size of the orbital. So you can see in this diagram, okay, in this diagram, you will see this is the schematic diagram of 1s orbital, and then this one is 2s. So when we compare, the 2s orbital is bigger compared to the 1s. And then we have this is the 3s orbital, which is bigger compared to the 2s and compared to the 1s. Okay, and then we go to the p orbital. So this is the shape of p orbital. It has a dumbbell shaped orbital, because there are two regions or lobes of high probability of one on either side of the nucleus. So the electron will spend equal time in both. So kita nampak kat sini dia ada dua loop. Okay, so the electron will spend more time here. Okay, so when we look uh, at the distribution, okay, the probability of distribution of electron, so kita nampak macam ni lah, dia ada dua loop, kiri dan kanan of the nucleus. Okay, so it has three spatial orientation. Okay, it has three spatial orientation, which is the first one is px, py, and pz. Why it has three spatial orientation? Because our our m value is -1, 0, and +1. Means that we have three value of m. Means that we have three spatial orientation, which is px, py, and pz. So what is the px orbitals looks like? Okay, what you see here, this is the orbital of px. So the loops, okay, the loops is lies on the, okay, if you can see clearly, the loop is lies on x axis. For py orbital, the loop is lie on y axis. So we have y axis here. Okay, this is the y axis, this is x, the atas tu z. Kalau you nampak, the orbital is on the y axis. Okay, if you can see clearly here, is the loop is on the y axis. Okay, how about z orbital? Okay, how about z orbital? So for z orbital, if you can see clearly, the loops is lies on the z axis. Okay. Okay. I will turn it a little bit. Okay. Kalau you also nampak, okay, this is the z axis. So the loop is on the axis. Okay, the last orbital is d orbital. So d orbital has 5 spatial orientation because if the d orbital will have value of L equals to 2, means that it has 5 value of M, which is -2, -1, 0, +1, and +2. So 4 of 5 orientation has 4 loops. Okay, it will looks like clover leaf shape. So kalau you nampak kat sini, kita ada 4 loop. So 4 of the 5 orientation has 4 loops. Okay, if you can see here, it has 4 loops. So the 4 orientation that has 4 loop is, the first one is the dx squared minus y squared orbital. Okay, so in this d orbital, you will see that the 4 loops, okay, 2 of the loops will lies on the x axis and another 2 is lies on the y axis. Okay, that is the orbital dx squared minus y squared. Okay, and then the second orbital is dxy. So how the dxy looks like? Okay, for the dxy, if you can see here, okay, if you can see here, the orbitals, okay, the 4 orbitals is lies in between axis x and y. Okay, if you can see here, the orbital is lies in between axis x and y. That is the dxy orbital. Okay, the third orbital is dxz. So if you can see here, for dxz orbital, the loops, the 4 loops is in between axis x and z. Okay, is in between axis x and z. Okay, you can see. And then, okay, if you can see clearly, the dyz orbital, the 4 loops will lies in between axis Y and Z. So the fifth orientation only has two loops, okay, with a donut shaped region around circling around the center. Okay, and then these two loops is on the axis Z. So the name of this orbital is dz squared. Okay, if you can see, there is a donut shaped region, the red one. Okay, uh, circling around the center, and then we have two loops that lies along the z axis. Okay, this is the dz squared orbital. Okay, next we go to the quantum number of electron. For quantum number of electron, an electron will specified by four quantum number. The first one is the principal quantum number n, two angular momentum quantum number L, and then magnetic quantum number N, and electron spin quantum number S. So I have explained about the above three quantum number. So right now, I will continue to explain what is electron spin quantum number. So electron spin quantum number is describe the property of electron spinning. So an electron spinning will have two possible direction. The first one is clockwise or counterclockwise. So you can see here the electron on the left side is rotate uh, in the clockwise direction. The electron on the right side will rotate in the direction of counterclockwise. So, electron spin quantum number can have two values, which is positive half and negative half. We will look at the first example. Okay, so let's say I have this quantum number of electron, n equals to 3, L equals to 2, m equals to negative 2, s equals to positive half. So what does it mean? So how this number relate to the electron? So from this quantum number, we can say that the electron, okay, the n equals to 3. The n equals to 3 here indicates that the electron is in shell 3. And then the value of L equals to 2 indicates that the electron is in subshell 3D. And the value m equals to negative 2 means that uh, the electron is in orbital either 3dxy, 3dxz, 3dyz, 3dx squared minus y squared, or in 3dz squared. So you may choose either one because you only have the value of m. You only have one value of m. And then the value of s, which is positive half, show us the direction of electron spinning is either clockwise or counterclockwise. And then we look at the example 2. In this quantum number, I have n equals to 2, L equals to 1, m equals to 0, s equals to negative half. So what does it mean? N equals to 2 here, okay, showing us that the electron is located in shell 2. L equals to 1 means that the electron is in subshell 2p, okay, because the value of L equals to 1. And then, because of the value of m equals to 0, means that this electron is located in the orbital, either in orbital 2px, 2py, or 2pz. Then the s value negative half, showing us the direction of electron spinning is either clockwise or counterclockwise. So you may choose one of the direction. So I hope that from what I what I have explained earlier, and with this example, you can understand what is the quantum number of electrons. Assalamualaikum warahmatullahi wabarakatuh.